Ladies and gentlemen, please welcome Senior Engineer from Ford of Europe, Joerg Hogefeld.
Good morning, ladies and gentlemen. I would like to welcome you to my lecture about automotive testing in territory in general, but especially cold climate testing under Arctic conditions, followed by a question and answer session. First of all, I would like to say a big thank you to the organizers of this event who have invited me and made it possible that I, as a representative of the Ford Motor Company, have the opportunity to talk to you and with you. I must admit that I'm an engineer at heart and could talk about automotive engineering all day. And I hope that I can present this information interesting enough that you would regard your participation here as worthwhile afterwards. My name is Joerg Hogefeld. I'm a senior engineer for in-territory testing and the trip leader for the Ford of Europe cold climate testing here in Rovaniemi. I work for Ford Motor Company in Germany now for 26 years already as one of the in total 171,000 global employees. My regular home base is the John Andrews Engineering Center in Cologne-Merkenich. I work in the in-territory testing and trip coordination team that is a part of the Vehicle Evaluation and Verification Department and belongs to the Global Ford Product Development Organization. Historically, Ford had always got major development activities in the US and in Europe. However, in the last couple of years, we have also built new development centers in growing emerging markets such as China, India, Mexico, and South America. The Ford of Europe research and development activities with around 5,000 highly qualified engineers and technicians are concentrated in Merkenich, that is a suburb of Cologne in Germany, and in Dunton, which is close to London in the UK. Our facilities also include a proving ground at Lommel in Belgium with more than 80 kilometers of different road surfaces built on 3,220 square meters of land. The engineering centers in Merkenich and Dunton have body, chassis, electrical and powertrain test laboratories as well as facilities to test complete vehicles. In addition, we have also got design studios, prototype build shops and wind tunnels there. In other words, everything that is needed to design, develop and test a new vehicle. For Ford of Europe, there are around 250 engineers and 500 technicians working in the Vehicle Evaluation and Verification Department who are responsible for all types of testing of the new developments. This Vehicle Evaluation and Verification team gives at the end of all these tests the so-called final engineering sign-off, which then allows the start of the mass production in the various assembly plants all over the world. On a global scale, Ford of Europe took over the development responsibility for all B-car and C-car sized vehicles and the transit. A B-car sized vehicle is, for example, something like a Ford Fiesta or a Volkswagen Polo, while a C-car sized vehicle is, amongst others, a Ford Focus or a Volkswagen Golf. Due to a split in responsibilities, my Merkenich home base is responsible for the development of the passenger cars. The Dunton Engineering Center has the responsibility for the transit commercial vehicle programs and for all powertrains. Now, I will try to tell you as much as possible about the automotive development and testing business, but please understand that this presentation can only be a high-level overview, and that certain information might be regarded as confidential, and I would not be allowed to give away any business secrets. You can see here, this is a picture from the entrance to our test facility in Zonka, that even for our own employees there are a lot of restrictions. For example, we don't allow any image capturing devices like cameras or even cell phones with cameras on the premises. I'm very sorry, but please accept that later I may also not be able to answer for confidentiality reasons some of your questions in much detail or certain aspects as you would expect. I will start now with an overview of the current automotive development process. But the prototype and testing portion is not very different between individual programs. The first and early steps will be depending on the type of vehicle program we are talking about. We separate between a completely new type of vehicle that has no predecessor or may even create a totally new segment, and a vehicle type that replaces just another current car. Other types of programs are, for example, body style editions, facelifts, new powertrain editions, or emission upgrades. A more recent challenge has been the implementation of totally new technologies like battery electric vehicles or hybrid electric powertrains or even fuel cell technology. I will come back to that subject again at a later stage of my speech. Usually, the company starts with an idea that gets then progressed by the creative people in the product planning department. Next in line would be customer clinics organized by the marketing department, where you show your ideas to selected members of the public for an initial feedback. Based on the reactions, you can either continue in the initial direction or you may need to alter the concept. The finance people will then calculate the pricing based on the estimated costs and the expected sales figures given from the marketing department. That will determine whether or not such a program has a business case, which means whether or not it would become profitable. If the program gets the approval from the director's board to continue, the concept then gets transferred to the engineering department to progress with the digital design work. Historically, the digital design got one day transferred into a real clay model. But nowadays, certain cars, for example, get developed without such an aid. The engineering departments then continue with the digital design, splitting it in system and component CAD and CAE studies. These get implemented into a whole bunch of virtual prototypes that could be digital bugs for a package analysis, but other virtual testing includes crash testing or wind tunnel simulations on a screen, for example, for engine cooling, airflow, suspension travel, and so on. Nowadays, you can even do durability testing simulations on a virtual prototype. All these development steps have altered the way cars and trucks get engineered quite dramatically in the last couple of years and have eliminated several physical prototype phases, which consequently save quite a lot of time and resources before the new vehicle can enter mass production. For example, for the first generation of the Ford Mondeo that got developed just 20 years ago in the beginning of the 1990s, we had built 4 prototype stages with over 650 physical bugs and development test vehicles. Today, we have just developed a similar sized program that went into production with 2 prototype phases and less than 100 physical prototypes. To give you an idea, the value and the cost to build such a prototype vehicle is around 500,000 euros. So with this information, you can imagine how much influence these savings have then on an overall program. Another major difference is the almost complete deletion of soft tooling for development parts, as the second prototype phase gets already built with 1 production released parts out of the final tooling. This level then is called the verification prototype and will be used for the final engineering sign-off. Because it is already looking very similar to the production design intent that should not yet be seen by the public, it gets usually heavily camouflaged when driven on public roads. You may have seen such vehicles already on the road around Rovaniemi, or at least on pictures in motor magazines. So here that is a sample where we use additional plastic parts for cladding of the body, that it is not possible to identify what the final design will look like. The reason for that is we, of course, keep producing the previous model, and we would like to sell it
And usually the next or the newer design is always more liked because it's fresher, it's new to the market, and therefore it's a competitive edge if we can keep it secret and people have not seen it before it gets actually launched in the media. Now we come to the main subject of this lecture that you may have already been waiting for, the in-territory testing of the prototypes. Here we distinguish between the different climatic conditions like cold, hot, or humid, geographic conditions like altitude, or surface conditions like low mu, split mu, dust, or snow. These testing conditions should always reflect the most technically demanding driving conditions any customer might experience in the markets this vehicle gets sold, and we try to emulate the worst case that puts the ultimate tolerable stress on the car and its components within the legal requirements or the limitations specified by the manufacturer and, for example, communicated to the driver in the owner's manual. We are fully aware that not many people actually read the owner's manual, but it's a legal requirement and part of the homologation, so therefore it gets bigger and bigger. Traditionally, such testing has been done in line with regular seasonal ambient conditions, but nowadays the shortened development cycles demand anti-seasonal testing in parallel, which is for the European and American manufacturers in the Southern Hemisphere. That means, while we are here doing the cold climate stuff right now, another team is running a hot climate test trip in South Africa at the same time. In general, these trips are split in high altitude testing, hot climate testing, or cold climate testing. The choice of the location is driven by the markets the manufacturer intends to sell the vehicles in, as this determines the conditions and the maximum and minimum ambient temperatures under which the product will be operated. Therefore, please understand that an identical looking car sold, for example, in the Arabian Emirates might have a different interior air conditioning and ventilation system compared with a car sold in Scandinavia, which then might have a larger battery and a stronger starter motor to cope with the ambient conditions in the respective market. Now we come to the part of our test trip tour in territory that is, of course, the part you might be most interested in, the cold climate and low mu exercises. Here, our European destinations are in Sweden and Finland, but additionally, we go to Canada or alternatively for anti-seasonal testing to the Snow Farm Southern Hemisphere Proving Ground that is located between Queenstown and Wanaka on the South Island of New Zealand. Another just recently opened alternative that applies new technologies and might somewhat revolutionize the automotive testing business if it works as intended, has been put into business at the Test World in Ivalo. This is a climatized indoor test road that allowed drive evaluations somewhat independently from the weather and ambient temperatures, and that can significantly extend the test season here in Finland. This is a kind of smart application of technologies that could give you some advantages in the future when you need to compete with facilities in countries that you just cannot beat on prices. So this is something that people must be really become aware of, that with the emerging markets coming up, it's not only an additional market to sell products to, but it's also a competition that the people there want to take over some of, for example, higher qualified jobs, and obviously with the lower wages there, they could offer such services cheaper. So to stay in business here in Europe, we must just be smarter and be ahead of them, so that there is still a reason why companies should keep, for example, development work here in Europe and not transfer it to the new markets. Nevertheless, other new cold climate testing destinations are already under consideration and might get built and put in operation in China or Russia in the near future. That is due to both the local needs in these emerging markets, but also the consequence of strong government intervention. For our testing under winter driving conditions, we distinguish between the tests that concentrate on low mu driving and tests where we concentrate on driving under the influence of the low temperatures. The low mu and split mu testing gets predominantly done on specially prepared surfaces at proving grounds in the Arvidsjaur and Arjeplog area of Sweden that are operated by large automotive industry suppliers like Bosch, Continental TVS or TRW. There, we concentrate on chassis and dynamic relevant systems like ABS, traction control, ESP, as well as some winter tire testing. Especially the ESP system performance checks are fairly complex because the driving safety depends on the functionality of individual and usually independently acting components like the engine, the brakes, the steering system and the tires. Further influences come from the vehicle speed, the surfaces driven on, and finally the driver reactions. Generally, the most difficult to detect driving condition the system needs to correct is a gradually increasing understeering, as different behaviors like sudden oversteering get noticed and correct much quicker. The cold climate testing that we perform in the Rovaniemi area is done on public roads as well as on private test tracks and on frozen lakes. So here, this is part of the test track that we have near Sonka, and this obviously is closed for public driving, and we can keep not only our product there in secret, but also can alter our driving speeds and so on independently of the legal requirements. In our facility at Sonka, we have a test track of about 3 kilometers length, and this is a major advantage for the reproducibility of our drivability evaluations after the cold starts, and we already think about potential extensions and upgrades to the existing test track. We do also testing on public roads, then obviously within the speed limits, and on frozen lakes, plus for all-wheel drive vehicles on our new test hills that got built by our local partner, Arctic Testing Services, last summer. In order to be able to have closely controlled cold start temperatures in the morning, we have access to cold boxes that can accommodate up to 17 vehicles at the same time. The temperatures inside these boxes can all be adjusted independently. So here on this picture you see the cold boxes that are part of the facility. These are more or less container-style buildings that could get moved around, but we keep them here in one position. This is very important for the engine calibration and the climate control specialists. In the main building of our facility, which is here, we get another picture soon. In the main building of our facility, we have a 600 square meter workshop for our technicians to work on the test vehicles. In the workshop, we can repair the vehicles, can instrument them with thermocouples and data loggers, can fit different levels of prototype parts, and we can update software and hardware as required. So here you see the interior, or actually the luggage compartment of a test car. So if you see such vehicles on the road, they do not get only driven from one point to the other for the passengers to enjoy themselves. So there is continuously data logging going on, and afterwards the analysis might take longer than the actual drive. In the same building next to the workshop, we have 600 square meters of office space divided in 15 offices for the trip participants to analyze these test data, have audio conferences with their respective home bases or other Ford locations worldwide to agree the test program for the following day. They can also stay in contact with their component suppliers or other experts in the subject. In our conference rooms, we can accommodate face-to-face meetings with bigger groups and can brief, for example, senior Ford managers that come for shorter visits to participate in the drive appraisals of their vehicles here on site. With the high-speed data lines installed, we have the possibility to connect them all to the Ford email system and to the internet as well. This is, of course, a major achievement compared to previously used facilities and makes the work of the engineers so much more efficient. So here you actually see that main building. The first part shown here are the offices. This is actually on 2 floors, and the second part is the workshop. We saw the interior before. Maybe it was a surprise for you to hear that a lot of our testing gets done out of cold chambers where the vehicles get conditioned under stabilized temperatures. This is done first of all to give us a repeatability of the test conditions, but also to reduce the time to be spent in territory while we don't waste our resources waiting for certain temperatures to happen. The temperatures we need to test under for the European markets are down to -40 degrees centigrade. So this is actually the backside of the building where we have a further group of cold rooms. But why do we actually need real cold climate testing in territory? Why do we not use only our simulation facilities in the home base? As you can imagine, we are often asked this question by senior managers because testing here on site is, of course, a relatively expensive exercise when a company has already invested in all sorts of facilities in their engineering centers. We have several wind tunnels and climatic chambers within our development centers in both Germany and the UK. The advantage of such facilities are that you can always do your tests under stable and reproducible conditions. You can adjust, for example, the temperatures, the humidity, or the air pressure to simulate altitude. Nevertheless, there are also certain restrictions. In our wind tunnel, we can test 6 to 8 vehicles at the same point in time, whereas here we can test up to 80 vehicles every day. Such large numbers of test vehicles are really needed due to the enormous number of versions available and the possible build combinations of modern cars, and in order to take into consideration the different production suppliers from the various assembly locations and thereby get good statistic relevance behind our test data. Cold climatic conditions are also not a real privilege of the northern European countries, but are also common in other parts of Europe, for example, at higher altitudes on both sides of the Alps, or in East Europe, mainly Russia, and of course in other parts of the world, such in the US, in Canada, and in some Asian regions as well. That means that driving under winter conditions is a real-world challenge for people in many countries. Just the severity might be different, and as I've explained before, with our grown engineering responsibilities within Ford of Europe for globally sold products, the importance of winter testing has even increased compared to the previous years. We really try to develop and sign off our vehicles under representative customer usage conditions. The closer we can get to the customer usage conditions, the fewer problems do the drivers and passengers have with our vehicles, and releasing a product without any major design flaws is a daily priority for the around 5,000 development engineers and technicians from Ford of Europe. Going in territory is still mandatory, as testing on-site provides benefits such as driving in line with the real customer usage conditions of the vehicles in really demanding driving environments. A realistic evaluation of the real-world drivability behavior after a cold start is simply not possible in a laboratory and can also not be simulated in any test facility. In our home base, we develop the base functionality of our products. Here on site, we continue with the fine-tuning under the cold climatic conditions. The same fine-tuning is of course also performed in hot climate conditions and in high altitudes. Here in Rovaniemi, we test in cooperation with our local partner, Arctic Testing Services, the following vehicle systems: engine cold start, cold drivability and warm-up behavior, transmission shiftability after the cold start, interior heater performance after cold start and during the warm-up period, interior thermal comfort with stabilized engine temperatures, window de-icing and window demisting performance, snow impact testing where we verify that all functions of the vehicle are still guaranteed if a large amount of snow accumulates in the engine compartment, in the wheel houses, and in other critical areas of the vehicle. Snow contamination of the windows plus the headlamps and rear lamps. That means, is the visibility for the driver still acceptable, and can the vehicle illumination still be seen by others? Other tests, for example, include snow chain mounting to evaluate the package conditions and the driving behavior, and the verification that vehicle functions are also guaranteed with snow chains fitted. So snow chain driving might not be very popular here or not get done very often, but for example in mountain regions around the Alps, it's a regular driving necessity and sometimes a legal requirement. So therefore we include it in our test work here. General drive evaluations of the complete vehicle under cold conditions that also include NVH performance. As a technical term, as used in the automotive industry, NVH stands for noise, vibration, and harshness. In addition to the dynamic tests, we also perform static tests. Can a customer, for example, remove the snow from a vehicle easily? And finally, we try to make sure that when opening the doors or the boot, not too much snow falls inside the vehicle. We call this snow ingress and egress testing. When he has finally entered the car, how does the frozen seat feel? Are the adjustment efforts still all right? Do the switches operate correctly under these cold climatic conditions? And do the door closures function without problems and so on? Finally, after the completion of the main cold climate test trip, we hand over some pre-production cars already built in the assembly plant to our local partner, Arctic Testing Services, for him to continue with some winter durability testing done in regular traffic conditions on public roads. So here you see a fleet of these durability cars parked in an industrial estate in Rovaniemi, from where a team of local drivers here from Rovaniemi start every morning and drive up to about 1,000 kilometers per day in shifts. I could carry on for some time now, but in the interest of time, this must be enough for now. You can all be assured that in-territory testing will also be needed in the foreseeable future. Also, it might need some further adjustments to cope with new technologies. Let me continue with some more numbers about our testing here. Our test season starts in late December and goes on up into early March each year. Every year, we test up to 130 vehicles during this time period. About 70% of these vehicles get, for example, transported here by ferry into the port of Turku and then continue their journey to Rovaniemi on the Finnish railway system. While these vehicles are driven here, they get refilled with about 10,000 liters of petrol and diesel, all purchased from local fuel stations in and around Rovaniemi. Additionally, we purchase up to 30,000 euros a year specialty fuels from a local trader. So these specialty fuels are either customized fuels made to very low tolerances, or they are samples of fuel that are usually not sold here on petrol stations in Europe, but represent specifications available in other markets like China or South America. Upon arrival at Rovaniemi Airport, our people pick up their rental cars, all booked from a local provider. During the previously mentioned test period, every winter, up to 200 highly qualified engineers and technicians fly to Rovaniemi via Helsinki, using Finnair flights exclusively to carry out their test and development work. Then they stay for about 2,800 nights each year in the local hotels and spend their expenses each evening in the restaurants and bars in town for the benefit of your economy. I hope that this helps you to understand the importance and advantages of the automotive testing business for the community here, as we are for sure not the only automotive manufacturer coming for testing. Hence, the total turnover figures from automotive testing in this region must be even significantly bigger. But why did we select Rovaniemi for the location of our new test facility? Maybe I start with a look back into the winter test history from Ford of Europe in Finnish Lapland. When I prepared this presentation, I actually asked some of my even older colleagues who came here already earlier than me, since when Ford comes to Finland to carry out cold climate testing. Nobody could remember exactly anymore. The best information that I've got is that we come here since 1968. This means for 45 years now. Initially, we started our testing in Rovaniemi before we moved to Ivalo, to finally come back to Rovaniemi in 1990. Actually, my first participation in a cold climate test trip as a Ford employee took place in 1988 in Ivalo. And since 1991, I come to Rovaniemi more or less continuously. As some of you may know, the majority of the test locations of our European competitors are located in Sweden. In the planning phase for the currently used facility, we seriously thought about such a relocation as well. We also considered doing our winter testing together with Volvo in their existing facilities in Sweden that are heavily supported by the local communities. I still remember exactly that we did a detailed comparison of all thinkable test requirements, logistics, climatic conditions, infrastructure, and level of support provided by the local communities, availability of hotel accommodation, travel costs, and so on. We had effectively many discussions and meetings on this subject before we made a decision, and then we had to finally convince the president of Ford of Europe that building up such a new facility in Rovaniemi would be the right thing to do for Ford for the future. Ultimately, he personally had to sign the contract for the 10-year rental agreement of this facility with our local investor and business partner Arctic Testing Services. The major advantages that convinced us to opt for Rovaniemi are the good environmental conditions, the usually extreme low temperatures in our test slot, the generous availability of snow, the good conditions of the public roads which we need for our tests, the very good logistic conditions which include flight connections from the UK and from Germany via Helsinki, and the good railway and ferry connections via Turku that are important for the transportation time and transportation costs of our test vehicles. A preferable hotel and restaurant infrastructure and the cost advantage of such accommodation compared to Sweden. And last but not least, the excellent on-site support provided by Risto Keskiruokainen from Arctic Testing Services and his team. This starts with providing us with winter tires, with special fuels for our vehicles, and ends with his personal philosophy. There is nothing impossible as long as Ford needs it or wants it. I would like to remind all of you in this room to build on the existing advantages of this region and continue to improve the infrastructure day by day. Do not stand still in developing further opportunities and efficiencies for the automotive testing business. One of our main tasks as a company every day is to improve the efficiency and to reduce the duration of our development process for new vehicles. This is very important in order to be able to survive in this very demanding environment for the automotive industry. Instead of your previous competitions with Sweden, the next challenges you might face will this time for sure come from the east. There will definitely be some future challenges coming from Russia, where they want to create some local expertise in engineering and will heavily invest in automotive development and test facilities, which will make it for the globally operating automotive manufacturers relatively attractive to participate in. Additionally, they created some legal requirements that make it mandatory for foreign companies to buy into a joint venture with a local partner for building production plants and at the same time agree a certain amount of engineering work to be transferred to this partner. I really hope that with our current state-of-the-art test facility, we can also continue to stay here for at least the next 20 years. But that would obviously require continuous investments to keep it that way and to allow us to cope with the new technologies. You can certainly imagine that efficient development and testing is a major requirement for us in order to stay competitive. This has become even more important in the current economic climate. A cost-efficient and quick development process with always new and interesting products in the market is a guarantee for the survival of a company like Ford. This means, in other words, that here in our current winter test facilities, we do not only test and development vehicles for the European market, we also test vehicles for later production in the United States, in Russia, and in China or somewhere else on the globe. Ford of Europe has taken over a leading role in developing the most fuel-efficient vehicles for Ford globally. And this grown responsibility makes it even more important that we can do our development work in modern and efficient test facilities. Therefore, we would like, of course, to make it possible to test our battery electric and hybrid electric vehicles here in the future as well. This requires, of course, an infrastructure available for recharging the batteries, as well as certain upgrades in the test facilities. Hence, it will require investments that we would need to discuss separately. This is actually the end of my speech, and I thank you very much for your attention, and you will now have the opportunity to ask some questions. I will try my best to answer them within the constraints explained before, but please understand that some details might be confidential and not yet be released to the public. Thank you very much.
Martti Hall from Barents Center. Thank you for a very comprehensive presentation. I have to make one little revelation. I have been working with Volvo since '74, but finally I do something else. But my question concerns the area here. If you should define the three major issues this area should take care of in order to keep Ford here, because we are very well aware of the fact with the Russian side, where you have one of your biggest production plants in Vsevolozhsk, only 200 kilometers away from the Finnish border, and that the conditions on the Russian side with the government and local authorities, it can always be negotiated. So therefore, it would be very interesting to hear what your suggestions are. What are the three major items we should concentrate on in order to keep Ford up here? Thank you.
Yeah, I think I tried to emphasize it during my speech. We must be aware that, for example, we can never compete with them, or you as our hosts can never compete with them price-wise. So we must together find out ways to be smarter and have the availability or the infrastructure to test also new technologies here. Obviously, these upcoming markets and where such facilities will get built, they have to keep up, but they will always be one step behind. I don't see a chance that they will be ahead of us and you in the near foreseeable future. Therefore, we must keep up our competitive edge and definitely need to invest in the availability of new technologies and to keep the infrastructure as good as possible. Thank you.
Thank you. I have two questions, actually. You mentioned that 200 engineers and technicians arrive to the Finnish Lapland, to Rovaniemi each wintertime for testing. Do you also include designers, design professionals in these testing teams from Germany? And the second question, because this is not, you know, a field I know very well, do you also use ordinary car drivers to test in winter conditions here in Lapland?
Yeah, let me answer the questions in the order you have asked them. So obviously Ford has several design centers all over the world, 2 major ones in Europe, but the actual work of the designers is in the beginning of the product development process. So when we come to here, the design has already been completed, and any alterations of the design that might become necessary for technical reasons would not get done here, but obviously in the home base. And therefore, we don't include designers in our teams here, but we stay in constant contact with them during our stay if we need them to become aware, for example, of shortfalls that would need to be addressed. And the second question concerning the drivers, yes, we employ several local drivers for the durability testing. That fleet shown here, we definitely want for this durability testing also some what we call non-experts that haven't got technical or engineering training. They should more or less drive these cars under regular conditions like an ordinary customer. Thank you.
Okay, which one is more demanding, surround extremely heat or extremely cold for cars, and why?
The more demanding environment is definitely cold. The reason for that is in a vehicle we have a lot of components that are a heat source. For example, the engine. You all know that an engine under running conditions becomes hot, and there are several components on an engine, like an exhaust system, that you should not touch with your hands. They get up to 800 degrees hot, degrees centigrade. And therefore, heat is a much more natural environment for components as well as a complete car to operate in. And you can include already protection against heat, for example, heat shields or insulation, but you cannot protect a car against the cold. So all the components and materials used must be able to withstand these cold conditions. And therefore, cold testing is much harsher and much more demanding than testing under hot climate conditions.
Good evening, or good day. One question about this design still, what Päivi was already starting here, because some of Finnish companies, they have started so that they use the designers during all the way. So maybe it could be also for Ford if you bring your designers to here to cold or also to hot conditions. So maybe they figure out something else than the engineers will figure. So it could be a really good design concept for your future cars, possibly. Maybe there is something like that. Could it be? Thanks.
I will definitely will address that suggestion in our home base, and I'm pretty sure that a lot of our designers would be very keen to join us on trips. The thing is, the development cycle of different products is also extremely different. So, for example, for a new car, from the creative stage where an idea gets put down on a piece of paper or on a design screen until that product becomes available for the customer is between 2 and 3 years. And the design stage is actually in the beginning of this time frame. And therefore, if we would alter the design during the final testing, then that would add another year to the development cycle, which would not only be a very costly exercise, but would also delay the launch of the product. So please understand that for products with a very short design phase, for example, like fashion, you know, we have several fashion seasons each year, and every year new products and new fashion styles become available. It's much easier to keep the designers involved until the end. If you have a product with a long lead time, for example, an aircraft, which has, again, a much longer lead time than a car, it would be a vicious circle if the designers would continue to update the product during the development phase. One of the reasons is tooling to produce sheet metal parts used in the body of a car or an aircraft. This tooling has a very long lead time, so the suppliers need several months to make such a tool, and if you then would like to alter the shape, it would start from scratch again. So therefore, it sounds like a good idea, and I would definitely support it. But unfortunately, with the current development process, it's not a very smart idea to keep the designers involved until the end. Yeah, I think that's all of the questions I can answer today due to the time constraints. So thank you very much for your attention, and I hope I see you again next year. Bye.